Imagine flying thousands of feet above the ocean at hundreds of miles per hour. Below you, there is nothing but an endless expanse of blue water. Above you, the sky stretches toward the horizon. Your aircraft is moving through turbulent air, surrounded by clouds, wind, and the enormous forces of flight. And directly in front of you is another aircraft. You are approaching it slowly. Not to attack it, not to intercept it, but to connect to it. For a few moments, two high-performance military aircraft must fly together with extraordinary precision. The distance between them becomes smaller and smaller until the refueling system connects. Fuel begins to flow. And somewhere below, an aircraft carrier continues moving through the ocean. This is aerial refueling. And for the F-35C Lightning II, it is far more than simply putting fuel into a fighter jet. It is one of the technologies that allows a carrier-based stealth fighter to extend its reach, remain on station longer, and operate hundreds or even thousands of miles away from its home base. The F-35C is the carrier variant of the F-35 family, specifically designed for operations from large aircraft carriers. It may look similar to other F-35 variants, but the C variant has been heavily modified for the unique demands of carrier aviation. Its wings are larger. Its landing gear is strengthened. Its structure is designed to survive the extreme forces of carrier launches and arrested landings. And its wings can fold to help fit the aircraft efficiently on a carrier deck. But there is another challenge that is less visible. Range. A stealth fighter may carry internal fuel, but modern combat operations are rarely as simple as flying directly to a target and immediately returning home. Real missions can involve long transit distances, patrols, waiting periods, maneuvering, training, defensive operations, and unexpected changes in the tactical situation. Every minute in the air consumes fuel. And that creates a fundamental question. How does a fighter remain in the air when its internal fuel is no longer enough? The answer is aerial refueling. For the F-35C, this capability can dramatically expand operational flexibility. Instead of being limited entirely by the amount of fuel loaded before takeoff, the aircraft can receive additional fuel while already airborne. That means the fighter does not necessarily have to return immediately to a carrier simply because its fuel is getting low. It can potentially remain in the mission area longer. It can reposition. It can support other aircraft. It can conduct extended patrols. And in a large military operation, that extra time can be extremely valuable. But aerial refueling is not easy. From the outside, the process can look almost effortless. Two aircraft fly together. A refueling system connects. Fuel transfers. The aircraft separate. But behind those few minutes is an extraordinary combination of engineering, training, communication, and precision flying. Consider the environment. An aircraft traveling hundreds of miles per hour is surrounded by constantly changing airflow. Even a small movement of the aircraft can change its position relative to the tanker. A slight change in altitude. A small roll. A tiny change in speed. Each one matters. The fighter pilot has to maintain an extremely precise position while the tanker aircraft is also moving through the atmosphere. This becomes even more impressive when you remember that neither aircraft is sitting still. They are flying through three-dimensional space. And they are doing it at high speed. The F-35C approaches the tanker and establishes the appropriate formation position. From the pilot's perspective, the tanker becomes a large aircraft occupying the forward view. The pilot must carefully manage speed, altitude, and alignment. The goal is not simply to get close. The aircraft must reach the correct position for the refueling system. And this is where an important technical detail about the F-35C becomes relevant. Unlike aircraft that use an external probe and drogue system, the F-35C is equipped for the U.S. Navy's aerial refueling boom system. A receptacle is built into the aircraft. A tanker equipped with a refueling boom can extend that boom toward the fighter. The boom operator then works to establish the connection. This is an incredibly precise operation. The boom must make contact with the aircraft's refueling receptacle while both aircraft continue flying through the atmosphere. Once the connection is established, fuel can begin transferring. And suddenly, the fighter that was losing fuel is gaining it again. This simple-looking connection represents one of the most important capabilities in modern military aviation. Because fuel is not just fuel. Fuel is time. Fuel is distance. Fuel is flexibility. And ultimately, fuel can determine how long an aircraft can remain useful in the sky. Now imagine the scene from outside. The F-35C approaches a tanker high above the clouds. The sunlight reflects from the aircraft's angular surfaces. The stealth fighter's distinctive shape becomes visible against the bright sky. The tanker maintains a steady course. The F-35C slowly moves into position. The refueling boom extends. For a moment, the aircraft appear almost frozen together. But they are not frozen. They are moving hundreds of miles per hour. The clouds below are rushing past. The atmosphere is constantly pushing against the aircraft. And the pilots are making continuous corrections. This is where human skill becomes just as important as technology. The F-35C may be one of the world's most sophisticated fighter aircraft, but sophisticated technology does not eliminate the need for trained pilots. In fact, advanced aircraft often demand even greater levels of precision. The pilot must understand the aircraft's behavior. They must monitor instruments. They must maintain formation. They must communicate. They must anticipate movement, and they must be prepared to disconnect immediately if something goes wrong. Because aerial refueling is not a single event. It is a controlled sequence. Approach. Position. Alignment. Connection. Fuel transfer. Disconnection. Departure. Every stage has to be performed correctly. And the environment can change at any moment. Turbulence can move the aircraft. Weather can affect visibility. Air traffic can create additional complications. Mechanical problems can occur. And because the aircraft are operating far from the carrier, the stakes are high. The tanker itself is a critical part of the operation. For carrier aviation, tanking capability has historically been essential because combat aircraft need to operate far beyond the immediate vicinity of the carrier. A tanker can act as a flying fuel station. Instead of bringing a fighter back to the carrier every time it needs fuel, the tanker can meet the aircraft in the air. This creates a kind of invisible infrastructure across the sky. The carrier is one part of the system. The tanker is another. The fighter is another. Together, they form a network that allows naval aviation to operate over enormous distances. And the F-35C was designed specifically to be part of that network. The aircraft's stealth characteristics are another important part of the story. The F-35C is not simply a conventional fighter with large wings. Its design emphasizes reduced radar observability. Its weapons can be carried internally in certain configurations. Its sensors are designed to collect and combine information from multiple sources. And its mission systems are built around the idea that information can be just as important as raw speed or weapons. But stealth does not mean the aircraft can ignore fuel limitations. In fact, the opposite is true. A stealth aircraft still has to travel. It still has to maneuver. It still has to remain airborne. And every one of those actions consumes energy. That is why aerial refueling remains important even in an era of advanced stealth fighters. Technology changes. The fundamental physics of aviation do not. An aircraft needs energy to remain in the air. And energy comes from fuel. Now imagine the F-35C operating from an aircraft carrier. The carrier is moving through the ocean. Its flight deck is crowded with aircraft, equipment, and personnel. The F-35C prepares for launch. Its engine comes alive. The aircraft moves into position. Then the catapult launches it from the deck. Within seconds, the fighter is airborne. But the mission may not be anywhere near the carrier. The aircraft may have to travel a long distance before reaching its assigned operating area. That is where the tanker becomes important. The F-35C can rendezvous with a tanker along a planned route. The two aircraft meet in the sky. The fighter receives additional fuel. And suddenly, its mission radius is no longer determined only by what it carried when it left the carrier. This can provide commanders with greater flexibility. The fighter can potentially spend more time where it is needed. It can support other aircraft. It can conduct patrol missions. It can move between areas of operation. And it can return toward the carrier with a greater fuel reserve. The same concept becomes especially important during large-scale operations. Modern air operations rarely involve a single aircraft acting alone. There may be fighters, electronic warfare aircraft, early warning aircraft, transport aircraft, helicopters, tanker aircraft, and naval vessels operating together. Each platform has a different role. The tanker